This is problem 11 from the review sheet. It says the IQs of individuals form a normal distribution with mean of 100 and standard deviation of 15. So if there's a mean of 100 and a standard deviation of 15, one standard deviation above the mean would be an IQ of 115. Two standard deviations above the mean would be an IQ of 130. One standard deviation below the mean would be an IQ of 85, and two standard deviations below the mean would be an IQ of 70. Estimate the percentage of the population that have IQs below 85. So we want to estimate what is this percentage of the population that's represented on the curve by this region down here, from here on over. That would be those that have an IQ of less than 85. And remember, when we work with the normal curve, there are certain characteristics of the percentages. And we can find the percentages by using the chart in our text that gives what's called the area under the curve, because the area under the curve is equivalent to the percentages. And the way we find the area under the curve is to first find the z-score of the data point we're talking about. So here, the data point we're talking about is 85. We want to know what's the percentage below 85. So we want to know from this data point to the left. So we first of all find the z-score of that data point. So that would be the data point minus the mean divided by the standard deviation. So we would take 85, and, well, we don't really need to do that, do we? Because you're right at one standard deviation below, aren't you? In fact, that's what the z-score really is. The z-score is standard deviations. Standard deviations above or below the mean. If the z-score is negative, which in this case it would be, the z-score here would be -1. That z-score is telling us we were one standard deviation below the mean. So 1.00. So if we go to the back of our text, and look up the chart to find the area, we go to the value of 1.00, gives us an area of 0.3413. And the area can be thought of as a probability. So if you chose a student at random, or a person at random, I should say, if you chose a person at random, the probability that they have an IQ below 85 would be a probability of This area, again, is not the region below. Remember, according to the chart, it's the area from the mean down to that data point. I almost made one of the cardinal errors myself. So it's the area from here to here that is the 0.3413 value. So to find the area from here to here, well, remember, the overall area on this half is 0.5. So we'd have to take 0.5 and subtract the 3413 from it. Yes, I almost made the cardinal error with these problems. So that gives us 1587 when we do that subtraction. So that would be saying the probability that you had a person who had an IQ below 85 would be a probability of 0.159, or roughly 15%, 15.9% of the population has an IQ below 85, which is what we were asked. What percentage of the population has an IQ below 85? So it's roughly 15.9% would have an IQ below 85. And again, the way we found that was by taking the data point and finding the area from the mean to that data point, which was done by getting the z-score, looking at our chart, and the chart always gives us the area from the mean to the data point. That was an area of 3,413 ten-thousandths. We had to subtract that from the 0.5 because this whole half is 0.5. The mean divides the curve, divides the area in half. So that gave us this value for the area, which when we convert that to a percent, gives us 15.9% of the population whose IQ would be below 85.